All right, this is the last new topic that we're going to learn for the test. If you look here, it says hydrates. Now, if you notice the word hydrate, it looks a lot like, well, when you think of the word hydrate, you think of water. All right, so hydrate is a compound when there is water, so compound with water, and hydrate has this and prefix, and basically means no. So no hydrate is a compound with no water. So what happens is if we have a compound that is a hydrate, say I've got calcium carbonate and it has water in it, then it looks something like calcium carbonate and it could have a 3H2O. That 3 just means that there are 3 times the amount of water. So here, if I have this compound and I heat a hydrate, that means that this water is removed. And now I have an anhydrate. So anhydrate is compound with no water. So when I write, my answer should always be written as compound times with a little dot. Don't do the multiplication symbol. That's not how it works. We have to use a dot. The number and then H2O. So I'm going to walk you through how to find this. Step 1 is to convert grams to moles. So if I look at this problem, I've got 0.737 grams of magnesium sulfite, 0.763 grams of H2O. What is the formula of this hydrate? So converting grams to moles. This is MgSO3, 0.737 grams. 1 mole at the top so that it can cancel out. Because that's what you're trying to find. Grams at the bottom so it can cancel out. Now, what should go into the gram box is the molar mass of the MgSO3. And I'm going to quickly show you that that is 104.38. But make sure you understand why it's 104.38. Do my math, and here I get 0.0071. The next part is finding the moles of H2O, 0.763 grams. 1 mole. Mass of water, H2O, is 18.016. Make sure you understand how I got that. I do my math, and I get 0.042. Now, step 2, divide by smallest of the answers. So it's very similar to the empirical and it's very similar to the molecular formula where you divide by the smallest answer, 0.0071. Top one, you get 1. The bottom one is close enough to 2 that I'm going to go ahead and round. Oh, I'm sorry. It is 5.92. That rounds to 6. Right? So then what I know is that in my formula, I've got 1 of the MgSO3, I've got 6 of the H2Os. So it's not broken down by individual elements like in the empirical formula. Instead, it's broken down by the compound. So I'm going to write my answer, should be written as compound, which is MgSO3. That dot, the number, and H2O. So I'm just going to put H2O. The number is going to be the number 6 because for every 1 MgSO3, I've got 6 of the H2Os, right? That's the extent of how difficult these problems get. So pause the video, do the rest of the math. I'm going to go ahead and tell you that for number 3, you can read through the problem, but I want you to just go ahead and write that you have 7.58 grams of MgCO3 and 8.09 grams of H2O. You can read through the problems and see how I get these numbers, but I made the problem more difficult than I want it to be. So here I'm going ahead and giving you the numbers. And for the last one, it is 3.22 grams of Na2CO3 and 1.09 grams of H2O. Like I said, I made the problems too difficult. Use the numbers that I give you here instead. Okay, for number 2, you have Na2CO3, 3.222 grams, converting it to moles. Molar mass at the bottom, the molar mass of Na2CO3 is 105.99. Answer here is 0.030. H2O, 1.09 grams. I know the mass of H2O is 18.016. My answer here is 0.061. Divide by the smallest of the answers, which is step 2, 0.030. Top one, I get 1. Bottom one, I get 2. Or it's basically about 2 if I rounded. So what I know is I have 1 Na2CO3 for every 2 H2O. So then I write my formula in the correct answer format. Na2CO3 multiply 2 H2O. Got my answer there.